This is Chapter 15, Organometallic Compounds, Part 2. And again, some of the audio apparently was not working about halfway through, so I'm going to kind of pick up and hopefully get through this with you. When you're doing these kinds of reactions, what we're trying to do is to make various types of alcohols using Grignard reagents, or you can use your organolithium as well. If you start off with formaldehyde, which is your simplest of all aldehydes, you're going to make a primary alcohol. If you start off with any other aldehyde, you'll make a secondary alcohol. And if you start off with a ketone, you'll make a tertiary alcohol. So this is just kind of showing you in general the reaction. So here you've got your Grignard reagent reacting with the formaldehyde in the presence of diethyl ether and your hydronium ion. You'll get your primary alcohol. What's going to happen is the alkyl group that's on the Grignard reagent is going to attach to the carbon, that's the carbonyl carbon. Your hydronium ion is going to provide your hydrogen that will be attaching to the oxygen to make your alcohol. So you can see the same thing here. This is just with an aldehyde other than formaldehyde, making a secondary alcohol. And then down here with your ketone, you'll make a tertiary alcohol. So let's look at some examples. So here's your basic formaldehyde, so you should know the basic structure. You have your 2 lone electrons on your oxygens up here. This can also be called methanol as a general IUPAC name. So here is our reaction, just showing you the mechanism. So here's our Grignard reagent. You're going to break this bond. This R group is going to attach here. This bond is going to rotate down here to get your lone electron. So when this breaks, then you're going to go to your R group is going to attach to your carbon, and then you'll have a lone pair of electrons. And then when you use your hydronium ion, that's going to allow you to, here's your hydronium ion drawn out. The lone electron pairs are going to pick up a hydrogen, making our alcohol group, and of course water will be a byproduct. Here's just a more specific example. So we have our cyclohexyl chloride here, or chlorocyclohexane, whichever you want to call it. That is going to react with this, and all this is doing right here is just making your Grignard reagent. So here's our Grignard reagent. And then we're going to react this with formaldehyde. When this reacts, then of course you're going to form, this is an intermediate, your alkyloxonium magnesium halide is kind of an intermediate, and then when you use your hydronium ion, you'll get your alcohol. If you use a secondary alcohol, as in this example, again, you're forming your Grignard reagent here. Here's our Grignard reagent. Here's our aldehyde that's other than formaldehyde. So this functional group is going to attach to the carbonyl carbon. This is going to be our alkyloxonium magnesium or alkyloxomagnesium compound. Then we'll do a protonation using our hydronium ion to produce our alcohol. If we use a ketone, then the only difference is you're going to make a tertiary alcohol. So again, that's just your generic reaction here, showing you that your R group is going to attach to your carbonyl carbon. Your electrons from the double bond are going to rotate here to be lone electrons. Then one pair of these lone electrons is going to pick up a hydrogen to create the alcohol. So this is just showing you the generic version. And here is a specific example, making the Grignard reagent, ketone, intermediate, when we do our diethyl ether, and then our hydronium ion, the protonation step, it's going to pick up the hydrogen from the hydronium ion and make the alcohol. Now esters can also be made. So here you have your here you have your Grignard reagent. Here you have this structure. And so when you react it with an ester, so this is your ester, and your diethyl ether, you're going to get, this is an intermediate. This is going to break the bond here and you'll form, in this particular case, you'll see that you're going to form this particular kind of a compound.